Hello students, welcome back. Hope you all are safe and fine. Today we begin with the topic square and square roots. In today's class, we will be discussing the following topics: square of a number, what is a perfect square, properties of squares of numbers, finding squares of a number without actual multiplication, and Pythagorean triplets. Let us see what is the meaning of square of a number. The square of the number is that number raised to the power of 2. For example, the square of 9 is 9 raised to the power of 2, which means you multiply 9 by itself 2 times. So when we multiply 9 by itself 2 times, we will get 81. Let's take another example. What is the square of 3? Square of 3 is 3 raised to the power of 2. This means 3 is multiplied by itself 2 times and we get 9. So the square of a number is that number raised to the power of 2. So what is a perfect square? A natural number is called a perfect square if it is the square of some natural number. What this means is 1 square is equal to 1, 2 square is equal to 4, 3 square is equal to 9. Therefore, each of these numbers 1, 4 is a perfect square because it is a square of a natural number. So 4 is the square of the natural number 2. Hence, 4 is a perfect square. Let us look at this table now. The number 1 has a perfect square 1, which means when you multiply 1 by itself twice, you will get the perfect square 1. The perfect square of 2 is 4. So what have you done here? You have done 2 raised to the power of 2, which means it is 2 multiplied by 2, you have got 4. Next, the number 3, the perfect square of 3 is 3 raised to the power of 2, which is 3 multiplied by 3. This will give you 9. In this way, you can write the perfect square of any given number, provided that it is a natural number. Now let us look at the properties of squares of a number. A perfect square is never negative. The square of an even number is always an even number. So let's look at an example. 2 is an even number. So if we have to take the square of this number, we will take it as 2 raised to the power of 2. So we will get 2 multiplied by 2, which is equal to 4. And 4 is even. So this satisfies the property that the square of an even number will always be an even number. The square of an odd number is always an odd number. So example, we'll take the number 3. To take the square of the number, it will be 3 raised to the power of 2, which is 3 multiplied by 3, and we will get 9. Let's take another one, 5. 5 raised to the power of 2 is 5 multiplied by 5, which gives us 25. So these numbers are both odd numbers. So this satisfies the property that the square of an odd number will always be an odd number. So let's look at the next property. A number ending in 2, 3, 7 or 8 is never a perfect square. So you have to look at the number, the digit in the units place. So if the digit in the units place is ending in 2, 3, 7 or 8, then you know for sure that this number is not a perfect square. So these are a few examples of numbers listed here. The number 72, 243, 567, 1098, they end in 2, 3, 7 and 8. So these are not perfect squares. The next property, a number ending in an odd number of zeros is never a perfect square. This means if the number of zeros after the digits is ending in odd, is an odd number, then it is not a perfect square. So let's look at these numbers: 690, 87,000 and 49 lakhs. Now these are ending in 1 0, 3 zeros and 5 zeros respectively. So these are not perfect squares. So if a number ending in odd number of zeros is not a perfect square, can you tell me what would be a number ending in even number of zeros? Would that be a perfect square? Yes. Square numbers have even numbers of zeros at the end, and square of numbers having zeros will always end in zeros. This property states that the number of zeros at the end of a perfect square is always even. That is exactly what I've said in the previous slide, that square numbers, a perfect square, will only have even number of zeros at the end. Okay, so let's take the example. The number is 300. If we are to find the square of this number, then you see that the square of this number, which is 90,000, it has even number of zeros. Now I have underlined the number of zeros. You can count, it's 1, 2, 3, 4, which is even. So it has a even number of zeros. Now this property also satisfies another property, that if the number is ending in 0, then the square will also end in 0. Here are some interesting patterns that you can take note of. If the digit in the units place ends in 0, then the digit in the units place of the square will also end in 0. Let's take an example. If the given number is 10, then the square of 10 is 100. Take note of the digit in the units place. In 10, 0 is in the units place, and in 100, which is the square of 10, 0 is in the units place. So this is satisfying this condition, that if the digit in the units place ends in 0, then the digit in the units place of the square will also end in 0. The next, it states that if the digit in the units place of the given number ends in 1 or 9, then the digit in the units place of the square will end in 1. So if the number is 11, where 1 is in the units place of 11, then we know that the square of 11 is 121. The digit in the units place of the square is ending in 1. What about 9? If we consider the number 9, the square of 9 is 81, and in the units place we have 1. So we know if the digit in the units place is ending in 1 or 9, then the digits in the unit place of the square will always end in 1. Okay. The next is, if the digit in the units place ends in 2 or 8, then the digit in the units place of the square will end in 4. So if we take 2, the whole square, it is 4. Now 2 is in the units place, and 4 is the square of 2, which is in the units place. Let's take 8. If 8 square is 64, the square, the digit in the units place of 64 is 4. Okay, so you can verify if what is written here is true. Take a number, and you find the square of that number, keeping the digit to be 5 in the units place, and see if the digit in the units place of the square is also ending in 5. It is a good habit to practice what you have learned so that you can become better. Now here are some exercises for you to practice. Here it is stated that the following numbers are not perfect square. What you have to do is you have to give a reason why these numbers are not perfect squares. So I'll give you a clue here. You look at the number in the units place of the given numbers. Remember the property of the perfect squares and accordingly assign a reason as to why each of these numbers is not a perfect square. The next one, you have to find the squares of the given number. So if we take the first number 14, it will be 14th square. Remember, it is the number multiplied by itself and write the square of the given numbers. The next is to determine whether the square of the following numbers will be even or odd. You don't need to find the square of the number. Without finding the square of the number, you just look at the number in the units place. Remember the properties that we have discussed, and based on that you write whether these numbers are going to be even or odd. Here is another interesting thing that we are going to be trying out, that is finding the squares of numbers without actual multiplication. For this we will be using the identity a plus b the whole square. Upon simplification we get a square plus 2ab plus b square. Remember, a plus b the whole square is a square plus 2ab plus b square. Now the question is to find the square of numbers without actual multiplication. So the given number is 39. So to find the square, we will write 39 square, which is written as 30 plus 9 the whole square. So basically what you've done here is you have broken up this number in the form of tens and ones. So it is 3 tens, which is 30, and 9 ones, which is 9. So we have written it in the form of a plus b the whole square. Now we have to simplify it, which is a square plus 2ab plus b square. So we know here a is 30, b is 9. So 30 square plus 2 bracket 30 multiplied by 9, that is ab plus 9 square. Now remember, you have to simplify the bracket, whatever is inside the bracket first, before you multiply it with the number outside the bracket, because we have to follow the rules of Bodmas, which is bracket, open, divide, multiply, add, subtract. So here after you simplify this, after you multiply 30 by 9, you will get 270, and then on further simplification you get 900 plus 540 plus 81, which will give you 1521. Let us look at a few more examples. Here we have 42. So 42 square is 40 plus 2 the whole square. So we have done 40 4 tens plus 2. So a plus b the whole square. Now simplify it, a square plus 2ab plus b square. So this is 40 square plus 2 bracket 40 multiplied by 2 close bracket plus 2 square. Now you simplify, 40 multiplied by 2 is 80. So 40 square is 1600 plus 2 multiplied by 80 plus 2 square is 4. Now add all the numbers and you will get 1764. Now the next one, this is 101 the whole square. Again express it in the form of a plus b the whole square. Then write it as a square plus 2ab plus b square. Simplify what is inside the bracket, then multiply it with the number outside the bracket and add all the digits, add all the numbers, and you will get the given solution. Now remember what we spoke about the properties of numbers. Does this satisfy the properties that we spoke about? That we said in the beginning that even numbers ending in the even numbers, the square will also be ending in a even number. So this satisfies that property that the square of a even number is always an even number. 42 is a even number and it is a even number. It's ending in a even number. Also we said that the square of an odd number will always be an odd number. Correct? Now let us see what is the meaning of Pythagorean triplets. Let's consider the following. 3 square plus 4 square is equal to 9 plus 16. So 3 square is 9, 4 square is 16. Now if we add 9 plus 16, we get 25. And 25 is the square of what number? 5. So that means 3 square plus 4 square is equal to 5 square. So 3, 4 and 5 are called Pythagorean triplets. So let us take a few more examples. Here we have been given two numbers 6 and 8, and we are asked to find the next number which would complete this triplet. So we will write 6 square plus 8 square. We will find the value of 6 square and 8 square. So we know 6 square is 36 and 8 square is 64. When we add 36 and 64, we get 100. And 100 we know is the perfect square of the number 10. So 6, 8 and 10 form Pythagorean triplets. Now if you are asked to verify if the given numbers are Pythagorean triplets, what will you do? You square the numbers and you see if the sum of the numbers is going to give you the perfect square. Okay, let's try this. So 5 square plus 12 square is equal to 13 square. So 5 square is 25, 12 square is 144 and 13 square is 169. So what you have done here is you have squared the number and you have found the value. Now you need to verify it. So to verify, what do? You will add 25 and 144 and see if you are actually getting 169. So if on addition of 25 and 144 you get 169, then that means this is a Pythagorean triplet because it is satisfying the condition 5 square plus 12 square is equal to 13 square. So 5, 12 and 13 are Pythagorean triplets. Now what is the formula to find Pythagorean triplets? For any natural number, let's take the natural number to be m, where m is greater than 1, then we use the formula 2m square plus m square minus 1 the whole square is equal to m square plus 1 the whole square. So here 2m, m square minus 1 and m square plus 1 form a Pythagorean triplet. Fine. Now let us take into consideration a few examples. Given m is equal to 2, find the Pythagorean triplet. Remember the formula 2m square plus m square minus 1 the whole square is equal to m square plus 1 the whole square. So here 2m. So given m is equal to 2. So substitute the value of m in 2m and you get 2 multiplied by 2 which is equal to 4. The next is m square minus 1. So we are going to take m square minus 1, substitute value of m, it is 2 square minus 1, 2 square is 4, so 4 minus 1 is 3. The next one is m square plus 1. So substituting the value of m, we get 2 square plus 1, which is 4 plus 1 is 5. So 3, 4 and 5 is the Pythagorean triplet. Now let me ask you here, why did I take 2m, m square minus 1 and m square plus 1? Why did we not take 2m square or m square minus 1 the whole square or m square plus 1 the whole square? Because we are not finding the squares of the numbers, we are finding the number. So we are considering 2m to be a number. So we are finding 2m, the value of 2m, which is one number. Okay. Next one, find a Pythagorean triplet whose one member is 12. So one member is given, which is 12. So we will take 2m is 12. Now if 2m is 12, we have to find first the value of m. So we will take 12 divided by 2. This is 6. So what we have found out now is the value of m. But remember 2m is one number, m square minus 1 is one number and m square plus 1 is one number. M is just the value. Okay, so now substituting m is equal to 6, we will find the next number. This is m square minus 1. Substitute the value of m in this, so you will get 6 square minus 1. 6 square is 36. 36 minus 1 is 35. So this is one number that we have found, which is 35. The next one is m square plus 1. So this is 6 square plus 1, which is 36 plus 1 is 37. Now the first number was given as 12. Don't get confused here. This is the value of m. We already know that amongst the Pythagorean triplet, one member is 12. So we had to find the next two members of this triplet. So we will do 12 square plus 35 square is equal to 37 square, because this is what the formula states. So after simplifying, you'll get 12 square is 144 plus 1225 will give you 1369. Now you add these two numbers, 144 plus 1225. Does it give you 1369? Yes. So that means these numbers 12, 35 and 37 is a Pythagorean triplet. Okay. This is something for practice. Please solve question 1, 2 and 3 from exercise 6.1 on your notebooks and question 1 and 2 from exercise 6.2 on your notebooks. Remember, as I've said previously, please see that you practice, solve the exercises on your notebook, and I'll see you next with a video on square roots. That's going to be what we are going to be discussing for the next class. Till then, stay safe. I'll see you soon with the next video. Thank you.